If you're wondering how to make a MongoDB repository with multi-tenancy, this is for you. And at the end of this video, I'm going to make an empty web application project to test the repository as a package. So I'm going to make an empty web application, install the repository as a package, and then test it out. You're going to see that it's very simple, very easy to use. There will be no domain infrastructure layers, and you will see that this is very useful. I hope you're doing well, and today we are going to build a repository pattern with multi-tenancy working with the MongoDB database. So I've created a class lib here, a simple class lib. I'm going to get rid of this class, and this should be your infrastructure layer. All of this code will be available on GitHub, so you can just go there and clone the repository and grab the code and put it on your infrastructure layer. So what I'm going to do is create a new folder for our interfaces. This will be the first thing that I'm going to do, is create a interface for the MongoContext. So I'm going to make a file IMongoContext. And with this context, when we implement this interface, this should hold all of the context regarding MongoDB. So the database name, the comments to execute, and handling the connections, the transactions, and the session. So everything will be handled by this MongoContext. First thing that we need is the default database name. Then the row to default database. This property, row to default database, is enullable because you can either have a multi-tenancy or don't have, and depending on your case, you can choose to have this property here or not. The row to the default database should be like, let's say you have a free row. Your user has a row that is free, and he is going to the default database, maybe a shared database. And if your user has a premium row, that means that he has another database or maybe his own database. Then when you're getting enable, is tenant enabled. And you don't actually need these three properties, turning this into a package so you can test it out. But if you do have tenancy or don't have tenancy, you don't need this property, and maybe not even this one. I'm going to show how to build this, and then I'm going to show how I actually have it on my own application. So now we need the iMongo database, which is an interface from the MongoDB driver, which I did not install. So let's do this. Package MongoDB driver. And this will install the latest package, which is the 3.5. Now I can reload the window. And there we go. So this will be our database. Then we're going to have a void add command. And you should have this method if you either have a multi-tenancy database or not. We're going to use this. This is related to units of work, and I'm going to show you later on. This will hold a asynchronous function, so we can pass a func task. I was going to write async, I don't know why, but this is a asynchronous function. And we are also going to have a save changes async. Two more things that we need here is the iMongo collection, and this will be a generic that will come from the get collection, and the string to the collection name. Last thing is just inherit from iDisposable. Now that we have our interface, we are going to implement it. I'm going to create a folder called data. And in here, I'm going to put the MongoContext. So I have my MongoContext class inheriting from the IMongoContext interface. I'm going to implement this interface, get rid of these errors here. Now we have two missing properties here. We need a private read-only list of asynchronous functions, and this will be our comments. This will be a list of comments. This is how we are going to do our unit of work. So we are going to create, update, delete, and all of these operations will be stored here on the comments. And once the unit of work save the changes, all of them are going to be executed at the same time. We also need a client session. We're going to call it session. Next thing we're going to do is make the constructor for this class, and since we need to do some work in this constructor, I'm not going to use the new way of doing it since the .NET 8 update. So I'm using the old way, like this. Here we go. And we just need one thing here, which is the eye configuration. Now you can see that we do not have the eye configuration here because it comes from Microsoft extensions. So we can come here to the CS project and we can make another item group, and this will hold a framework reference. So we are going to include Microsoft.asp netcore.app. Because of the multi-tenancy, we are going to need this later, and this solves all of our problems. So now in our MongoContext, if we come here to the eye configuration, we now have access to the Microsoft extensions. Now another property that we need that I forgot about is the Mongo client, right? Without this, we can't actually get our database, and it's public. So we are going to make a Mongo client called client and new. And we have to pass a string here, which is the connection string to the MongoDB database. So I'm going to get it from the configuration, the appsettings.json file from the configuration interface. So I'm going to get section MongoDB and then the connection string. Now this connection string cannot be null, so I'm going to make a new folder called exceptions, and this will hold all the exceptions regarding this repository. Here I'm going to make a exception called missing MongoDB configuration exception. And this is our exception. It's very simple. It's a missing MongoDB configuration exception. We are going to pass the property that we are missing from the appsettings.json file. And this will throw an exception with this message and property. So now here in our MongoContext, we can say that if we don't have a connection string, if it is null, we are going to throw a new missing MongoDB configuration exception. And what we are missing is the connection string. Now we can assign the Mongo client to this client. And we do the same thing for the other properties we have here. The is tenant enabled, the default database name, they are both mandatory, and the row to default database can be null, so yeah, everything's good. Now we could do database and pass the database from the client.database, and pass the default database name, and then we would get the database that we need from MongoDB. However, we are working with multi-tenants, and if you have a default database that is maybe a shared database, and then for each user, for each tenant, you have another database for them, then we have to make some changes here. So two things that we need, first of all, is a user information interface. So I'm going to make a iUserInfo.cs. You don't have to make this interface if you don't want to. You can make like a user info class or another class to represent the payload in the JWT. So here I have a iUserInfo that will get a key to the ID and the tenant ID that comes in the JWT of the user. However, you can also have an ID and a different type for the tenant ID in your system. And this is why I'm making an overload in the generic, but you don't need to. If you know the types of your system, you can just make like a class, user info class, and then pass the types here like int and GUID, or maybe everything is GUID, but this is up to you. I'm making this generic so you can test it out in the package. But like I said, I'm going to show you how I actually have it in my system. So in my actual project, I have this class user info, and with the user info provider that we are going to do in a minute, and you're going to see that I have some overloads that you don't need to do. You just need this, the user info with the HTTP context accessor, and then the get user information with your user info. The point here is to deserialize the payload from the JWT into your class. And this is how my user info look like. I have a tenant ID, I have a JWT rows, and then some specific properties to my system. I'm gonna keep this project open because I'm going to be comparing. This project is multi-tenant, that's why I have this user info in here. So I can get the tenant ID and filter in the database. And I actually use an identity service for authentication and authorization, and in this service I only have authorization. And this works because the JWT key is the same. If you want to know how to make a dedicated service for authentication and authorization using ASP identity, leave it in the comments and I'm gonna do it. So we have our iUser info interface. Now we are going to make our provider, just like I showed you. New folder, providers. Okay, so in our user info provider, we are going to have only two properties. We are going to need a private read-only HTTP context accessor, HTTP context accessor, and this will get us the JWT, and then we can work on that to get the tenant ID. The other property that we have is the iLogger, but you don't have to log, but it is a good practice. And both of them comes from dependency injection. So you can just put on the constructor and let .NET handle it for you. Now, like I told you before, I have this get user information twice because of the generic overload, but you don't actually have to have this if you know all of your types, the types to your IDs. You don't need to have this. You can have, just like in my project here, just one get user information with your user info type, and that's it. So basically what I'm doing here is checking if we have our token, if the barrier token, if the JWT is coming in the authorization header in the HTTP request. So If the HTTP context is null, we are returning null. And if there is no token, we are also returning null and logging that node JWT to get the information was found. But in your application, you can handle in a different way. I'm just going to show you how we can use this tenant ID. Down here we have the payload in bytes, and then transforming this into a JSON string. And this is the actual object, but as a string, as a JSON. And then here we do the deserialization. So that's basically it. We have also the get user JWT function, which is just to return the JWT itself as a string. We don't go through this process to transform this into a JSON. We just return the whole JWT. So now that we have our iUser info, we can actually get the tenant ID. So I'm going to do iUser info, and then we need a key, okay? And this key will come from the MongoContext. We pass here a T key, and here we are going to have a nullable user info variable. And then we need to have also a user info provider in here through dependency injection. So we are going to get our information as a T key will be the keys. Now we can check if we have a user info, if user info is not null. And this should be enough for your project if you're using multi-tenant, but I'm using generic, so I have to test if the tenant is enabled, and also if the user info.tenant ID is not null. Now, all of this, you can adapt this to the nature of your application. So if the user info is not null and we have a tenant ID, we are going to do something. If not, we are going to use the default database. So what we are going to do here is basically check if we are supposed to go to the default database. To do this, we are going to see if user info.rows contains the row to the default database. So let's say that your row to the default database is free, right? The user has a free account, and then he's going to the default database, which is maybe a shared database. We need to check if the user has this row in his JWT. So now we are going to get the database name. Now we are going to make a to default database and a ternary condition. If we are supposed to go to the default database, we are going to just pass the default database name. However, if the user is premium or he doesn't have the default database role, we are going to use his tenant ID as a string as the name of the database. Now we are also going to need another exception because this cannot be null. If we have a tenant ID, this cannot be null. So we are going to make a new exception for that so we can get rid of that warning. This will be unable to get tenant database name exception. And basically we are going to say not able to get the tenant's database name through the tenant ID, change its type, which I recommend in GUID, or clone the repository and change the properties. Because you may not want to have the tenant ID as the name of the database, so you can clone this repository and then change it for what you want to. So in here, if this is null, we are going to throw new unable to get tenant's database name exception. Now with this, we can do the same thing as we did in the else, but instead of the default database name, we are going to pass this database name. And there we go, we are done with the constructor. Let's go to the methods. The first one will be the get collection. And I'm basically going to do database.get collection, and then also this T, this generic, and the collection name. And there we go. It is that easy. To add the commands, this is also easy. We just need to do comments.add and then the function. And now we are going to do the save changes, which is a bit more complicated than that. We're going to do a using session because we don't need this session. We just need this session to save the changes. We are going to get the Mongo client start session async. Now the save changes, we need to start a transaction, execute the comments, and then close the transaction. You can only use transactions if you have two databases, if you have a replicate set. So be careful with that. But now we can do a session.start transaction. And then here we are going to have a list of the async comments that we have. So we're going to say select and then call this function. Now we are going to await task.when all comments. So you could use parallel here and use a for each or a for async and execute all of the commands at the same time. However, this would break the order of execution. You may think that this would be faster, but this would actually cause a lot of logic problems. After this, we can close our session, so we can await the session dot commit transaction async. After committing the transaction, we don't need this session anymore, so we can do the rest down here. And we are going to clear our comments because we are done with this unit, right? We executed these comments, we called the unit of work, executed these comments, and now we can clear these comments. And also we need to return the comments count, right? We just need to save it up here. We just need to do this before we clear the list. So there we go. Now in the dispose, this is from the iDisposable. We're just going to check if we have a session and then also dispose this session. And also give a warning to the garbage collector to not finalize this instance. So I also did another MongoContext, and this is MongoContext with other tenant ID type. This is just another file so I can do an overload in the MongoContext using another type for the tenant ID. And once again, you don't need to do this. I have just one MongoContext on my application. So this is my MongoContext. You can see that I don't have a tenant. I don't have a default database. I just have the connection string. I connect to the client. I check if there is a JWT to go to the right database. And I also have these apps rows, which are the rows of the application. And if the user have a free row, he's going to the free database in the shared database. And the default database is also the shared database. And everything is pretty much the same thing. Okay, so now we are going to the actual interface for the repository. So we are going to make a new repository. And I already have this ready, so I'm just going to copy the code and then tell you a little bit about it. So first thing that we need is AT because this repository is generic. So we're going to need a T, and this comes from MongoDB. So I have an overload here. You can create a sync one single entity, or you can create an array of entities and maybe pass the options. And this is from MongoDB. And you also have the cancellation token here. We are going to do the same thing for the update, just with different options. For update, you have replace options for one single entity and book write for many entities. And now we have 5 methods to read the database. So we can just import this expression, and you can see that we have a T key, and this should be the ID of your entity. So we need another thing here, which is a T key, and we can also inherit from a disposable. Now, when we implement this interface, we need to have a tenant ID and ID in this T, because when we filter, we want to filter if you're using multi-tenant, you want to filter directly in the database, and for that you need to have the tenant ID included in this T. And this is how we do it. We are going to declare an interface here called iEntity. So here's the iEntity interface. It's very simple. Ignore one of these. You only have the ID and the tenant ID. I'm only making this generic once again so you can install the package and choose the type that you want. So here we have the same type for ID and tenant ID, and here we have one type for ID and another type for the tenant ID. If you want to make an GUID ID and then an integer ID for the tenant ID for some reason, you can do it. In my system, I have just an iEntity interface, and both of them are a GUID. And this is in a package because I have a lot of services and they all have access to my main domain. So with our iEntity, we can say that where T inherits from iEntity, and we also pass this key. Now there's also another thing that we need to do, which is say that this key is not null, because that's what we defined it here on this interface. This key must not be null. So we can come here and say where T key not null. And this will solve our problem when we are going to read from the database. Now we can delete the database, and we can delete one single object, we can delete an array of objects, or we can pass a condition to delete a couple of objects, or a filter definition from MongoDB and delete these objects. And actually in MongoDB, delete the documents. We're also going to do some counts, so we can count everything. There's only the cancellation token in here, or we can count a specific entity, or we can count based on a expression. Okay, once again, I did an overload of the generic. You don't need to do this. You can have only the one iRepository. This is what I have. I only have this iRepository T, which inherits from disposable, and T must inherit from iEntity. That's it. So now we can do our repository. I'm going to make a new file, repository.cs. And this repository will be an abstract class repository. And all of your repositories should inherit from this repository, and they will have all of the methods already implemented. So we must have a T and a T key. In your case, if you know, once again, if you know the types of your IDs, you don't need the T key, only the T. And we are going to inherit from iRepository. Passing the T, passing the key. And we also need the same rules for the T and the T key. So we need to do this T key not null and T must inherit from identity. Now we can implement the interface. And I'm just going to reorganize this. I'm going to put the count at the end. I'm going to put the dispose at the end. And I'm going to put the read part of our CRUD in the beginning because this is the most interesting part. So in the getAsync method, we want to return a list of objects based on expression that can be null. If it is null, we are going to return everything from the database. So in order to do that, we are going to try a list, which is going to hold all of our objects, and this is what we are going to return. And once again, we are going to check if we have a user info, so we can filter on the database. For that, we need a user info provider, so let's put this up here. On the constructor, we are going to have a user info provider. We also need the collection name to get the collection to work in this repository. We also need the IMongoContext. And I'm also going to put here the logger, but you don't have to. And this is how it looks like. IMongoContext will get the context. The collection, we are going to use the context to get the collection using the T, which should be any type that you have, any entity that you have, and then the collection name to get the collection. The user info provider will get the user info and the logger, the logger. So now, last thing we need to do to make this work is async. And I am missing this MongoDB CRUD exception. So I'm going to make this. Basically, this exception is just to tell you that there was a problem trying to do some operation. That's just it, just so you know that this comes from this repository. Next method is the getById, and this is pretty much the same thing as the getAsync, but instead of having an expression that based on a condition it should return a list of objects, we are going to return just one object from the ID. So instead of a list, we have only the T. We are checking if there is a user. If there is a user, we are going to check if in his rows he has the default to the database. If the user is not null and he has the row to the default database, it means that he is on the shared database. Then we can filter by the tenant ID. So we do a collection, find an object where the ID equals the ID that was passed in this function. And the tenant ID is not null, and the tenant ID equals the tenant ID from the user. And this is how we filter in a shared database. We check if there is the user information. If there is a HTTP request, then we are going to access this HTTP context, get the JWT, transform this into the user info, and then get the tenant ID directly in the database and filter it directly in the database also. But if there is no user info, we can just get the ID because this is the specific database to the user. We are already on the database, on the user database, because that's what we defined in the Mongo context. If there is no user, if there is no HTTP request, we are going to the default database. But if there is an HTTP request and the user is not uh, does not have the row to the default database, which means he should have his own database, then we are giving the database name as the tenant ID. And here on the repository, if the user info does not contain the row to the default database, then it means that he has his own, and we are working on that. We also have this get1 async, which is pretty much the same thing as the get by ID, but instead of the ID, we pass the entity, we pass the object. Now, you may think that this is stupid, but you can have like an incomplete entity. You can have only the ID and you need the other properties from the database. Then you can pass the whole object in here, but it is in fact unnecessary. You can use only the get by ID async. It's just here if you want to use it. The get one with a expression, this one is not so useless. Here you can get one entity based on a filter, based on an expression, on a condition. So here we do the same check. We check if there is, we do the same check. We check if the user info is not null, and then if he is on the default database. If he is on the default database, which means he's on a shared database, we are going to do this tenant filter. And then we are using this builder because we want to do both filters. We want to filter the tenants and we want to filter whatever we want to filter here. If the user info is null, which means that you are either not using multi-tenancy, or maybe you are doing a seed, or if your user does not contain the row to the default database, and this is wrong, we row to the default database, then we are also going to work directly on the database without a filter because we are on the right database in the tenants database. Now we can do also queryable. We can get a collection as queryable, and here I'm getting as queryable and then doing a filter on the tenant ID. And since this method does not use async, I just do a task.fromResult and then pass the queryable. Now we have the create method. Basically, we are going to add a command in the context with either insert one entity or insert many entities. And here we are going to pass the insert options to the insert many or insert one methods. Then we are logging the information, returning that the task is completed. We also have catch in everything and logging the error and then throwing a custom exception so we know where to make the fix. So now we have the delete method, which is pretty much the same. We are going to delete one and then checking if the ID equals the entity ID. And here we are deleting many, passing in the entity. And here we are deleting many and then selecting only the ID from these many entities and checking for each document if they have the same ID in this array of IDs. Now we also have the delete with expressions based on conditions. So we can delete many with a filter that is an expression with a function t and returning a bool type. And we can also use the filter definition, which is from MongoDB. Now we also have the update where we can replace one, which will basically, even if we change just one property, we are going to replace the whole document with this new entity, with this new document. And here's the same thing. First, we are going to check which document we want to replace based on the ID. and then we are going to pass the new values of it, and the options and the cancellation token. And same thing for the update with many, with an array, but we are going to use a book write. And then we need to also have the updates that we need, the IDs that we need to update. So what we are basically doing here is a list of replace one, and then we are passing the filter that we need for each one of them, checking it by the ID. And after this filter, we also pass the object itself to replace based on this filter. And now for the count method, we can check also if there is a user info. If the user info is not null and if he's on this shared database, then we are going to count the documents just for this user, only for this tenant. Just to clarify, tenant and user are different things. You can have maybe 3-5 users in the same tenant, but if there is no user info, or if the user does not have this row to the default database, then we are going to count with no filter, with an empty filter. Here we are doing the same thing, but with an entity, with an ID, to check if we have duplicates, which should not happen. So if you want to get rid of this method, you totally can. And last one, we also have a count with an expression, so you can count based on a condition. The thing here about multi-tenancy is just this user info, right? I am trying to get directly from the HTTP request, right? I'm on the infrastructure layer, and I'm trying to get from the HTTP request the JWT, and then I'm taking the payloads from the JWT, and I'm trying to get the tenant ID from it. Once I get the tenant ID from it, I'm going to check here if the user info is not null, if I did get the user info, and I'm going to check if he has the row to the default database, to this shared database, so I can filter with his tenant ID. Then down here I have the filter with the tenant ID as I have in the other methods, and all of this will be on the GitHub if you want to copy all the code or clone the repository, or you can check it for yourself. But this is the magic of it. We are filtering the tenant ID directly on the request on the database, so we have way less information when we use this repository. So once again, I copied the file, I did a repository with other tenant ID type just to do that overload on the identity, on the iUser info also. And like I said before, you don't need to do this, and I'm going to show you again that here on my repository I only have this T, and I have the collection, the context, user info, and I have the iRepository T, where T inherits from iEntity. No T key, none of this generic regarding the ID and the tenant ID. I'm going to scroll through here so you can see how everything is working here. You can see that I use directly the user info. There is no T key, there's none of that. I'm not using the context also, I'm using these app rows and then the row that I defined. However, the filters are the same. I am filtering through the ID, I'm filtering the tenant ID based on if I have the user info and if the user info has a free row. So it's pretty much the same. I'm just doing more generic, so you have more flexibility to work on it. And I'm also going to do it as a package, so you can test it out for yourself as a package before actually cloning the repository and trying it out. So last thing that we need to make this work is the unit of work. We already have the repositories, we already have the context, which holds the commands, we have the repository, to add the commands, the creates and the deletes, and now we need the unit of work to commit all of these commands. So I'm going to create a new interface here, which is unit of work. And this unit of work is very simple. It inherits from a disposable and it has a commit async, and that's it. The only job from unit of work is executing the commands. So now we can implement this unit of work here in the data, and the only thing that it needs is the MongoContext, of course, to call the save changes, and that's it. If the change amount is greater than 0, it means that everything went fine. And we also have the dispose here, which is the same as before. Just a quick note here, I'm just going to make all of these methods virtual. This means that if you inherit from this abstract class, you can override this method and then write anything that you want. So I'm just going to quickly make everything virtual, and then we are taking one more step. Okay, so the next step here is making this base entity that your entities should inherit from. Once again, I have this T key, these generics that you don't need. Here's how I actually have my base entity. It is just a public class called base entity that inherits from the entity, which already has the GUID defined. So I know that this is a GUID, and I already instantiated, and I also have this tenant ID nullable. And you can see that on the interface it's the same thing. So there is no need for you to do this base entity T key. Just make it simple, set the type of the IDs, if they are strings, if they are GUIDs, or if they are integers. Once again, I'm just making this generic so you can test it out as a package. One more thing to do here is the configuration file that we need. So let's create a new folder called configurations, and this will be a static class with static methods called configure database. Actually, it's just one method, it's just one static configure database. You don't need this generic. I have two of them. I have the configure database and this one, but you don't need two. We are basically making an extension method in the .NET services, in the iService collection, and then we are getting the iConfiguration as a parameter. Here in this line, we are basically saying that the GUID will be a string in the database. Then here we are ignoring if we have some property that is null or extra, it will be ignored. Here I have a iLogger factory that you don't need. If you have a logging system, you can set it up here. Then I'm also getting if the tenant is enabled, you don't need this, you just need these services. You just need to add the services here. The user info provider, the IMongoContext, and the MongoContext key, and the unit of work. And here I am just checking if the tenant is enabled. If it is not enabled, if you are not using tenants, then it's just going to ignore the tenant ID. Now I actually made a project, a API test, and here I have this MongoDB repository installed as a package. But this package is a test and it is on my GitHub as a private package. But they are the same, this test and the one that I just showed you, they are the same. The code that I was copying is from this test project, and this is very simple. This is an empty API. I did a .NET New Web, and the only thing that you need is to add the HTTP context accessor, regardless if you are using tenancy or not. The fact that I have the HTTP context accessor interface in the repository means that you need to add the HTTP context accessor. If you don't want to add this, if you're not using tenancy, clone the project, put everything on your infrastructure, and then remove the things that you need to remove, which are unnecessary. To configure the database, we basically pass the type of the ID that we have. And in this case, I'm saying that all the IDs are GUID. Okay, I'm saying that the user info ID will be a GUID, the tenant ID from the user info will be a GUID, and the tenant ID and the ID on the entities, on the documents on the database will all be GUID. Okay, but I could do a GUID here, and then the first GUID is for the tsub, which is the user info ID, and then you have the type for the ID in the documents, which can be an int, and then you have the tenant, which is the tenant ID that is on the document and also on the user info, and this can be a GUID again. However, I'm just letting everything as a GUID, and that's the only line that you need, this configure database, which is the extension method that we did. Then you pass the builder configuration and you're done with the configuration of the database. Now you need to add the repositories. We are going to do add scoped, and then I created 4 entities with 4 different types of ID, just to show you that it works. So we have this animal repository, this fruit repository, the car, and the post repository. If we come here to the repositories folder, you're going to see that this is very simple. I have this animal repository, which will have a IMongoContext through dependency injection, also the user info provider, and we are inheriting from that repository abstract class that we had, passing the animal as the generic, right? So we had, let me open this up real quick. So here on our repository, we have this T and this T key, which represents the ID, the type of the ID. But this T is the type of the entity. So everything that is here, this function, this enumerable, will return a list of animals, and this will have a type of animal. In this case, in this scenario here that we are passing animal, and the ID will be an int. Then we are passing the collection name, which is animals, and the same thing happens for all the other repositories. So all of the repositories have a type of entity, and they also have a type of ID, which you don't need to have it. You can have just only one type of ID, which is the proper way of doing it. But I'm just going to show you that this works. So you basically have all of these repositories. Then here we have a get. So once the API starts and we open it up on the browser, this is going to be executed. And we are getting from the service all of these repositories. We are getting the animal, the fruit, and the car repository. Here we are getting the interface, but the interface, as we declared here, will be replaced by this animal repository. And we are also importing the unit of work, which we don't need to add as scoped because it already exists on the configure database. We are already added the line. So here we are creating animals, fruits, cars, posts, and then we are executing this create async with the list overload, and then we are using the unit of work to commit everything and returning a it works message. Now, one thing that is very important is the app settings. You must configure this MongoDB object here on the app settings file. So here we have the connection string, which we have 2 databases, one running on this port, another one running on this port. And we have the replicate set and the replicate set name. Then we also have the tenant ID, is tenant ID enabled, and I put it as false because I'm not using tenancy. There is no JWT here, there is no identity here. So I put it as false, I set it as false, and the default database name is testing repo. Now, let's put it to the test. So here I'm going to run two databases using this command, MongoDB, and then the port, passing the port, and the DB path, which is just a folder holding all of the information in the replicate set name. So I can execute this for the port 2717, and then execute the same command to the port 2727. Now both databases are running, so I can come here and test. I can do a Mongo shell, and then I tell him the port that I want to access. And here I am. Now I can see the databases. You can see there is no testing repo, right? There is no testing repo, which is the name that I gave to the default database name. So once we open the API, the endpoint, it should create it for us. So let's give it a .NET run. It is up and running. If you had any errors, please let me know in the comments. Now we are going to open it in the browser. And you can see that we have this message. It works, so probably everything went fine and we have all the data on the database. So we can do a show DBs again. You can see up there that we have no testing repo, and now we do. So we can use testing repo, show collections. Here are the collections that we created, all of them. So let's do a db.animals.find. And there is the data. And then we also have cars. We also have fruits. And we also have posts, which is date time. So we have an ID type of date time, which I don't know why you would want that. We have a GUID type for fruits. We have a string type for cars. And we have an int type for animals. Now, some of them are not showing the tenant ID because I set it the tenant ID as false, is tenant enabled as false. So here on the appsettings.json, I have the is tenant enabled false, which means that in the repository in our project here, this is false. The tenant is not enabled, and we are ignoring the tenant ID for this T key. Okay, so we passed a GUID in this project in the API. We configure the database as GUID here, so we are ignoring all the tenant IDs that are GUID. But you can see that it worked. You didn't have to create any layers. We only did like 4, 5, 6 lines of code. We installed a package, we did 6 lines of code, and we already have everything running and everything working on the database on the MongoDB, and we can even adapt this to work with Multi-Tenancy. This project will be on GitHub. The link to this project will be on the description. If you liked this project, if you like this repository, if this video helped you, and if you want to learn more about software development, make sure to subscribe and hit the bell so you don't miss anything. Thank you for watching, and I will see you in the next one.